time to get onto the thing, we can just go...
We're late for maths! Again!
Wow, that was quick. How did you even get in front of me? I'm the doctor.
No one was here.
Oh, the clocks went back, didn't they? Oh, nuts. We're nearly an hour early.
What did you know? We're back. On to A2.
Yes, I hope your ASs went well.
Yeah? If they did, hope you can share our videos and help other people as well.
Yes.
Oh.
And if they didn't, just because we're on to A2, we're still here to help with AS and GCSEs for that matter as well.
All questions we will answer in detail.
Yes, just the same as before. So, new book,
new topics,
new hat,
and a new drink.
Not tea anymore.
It's coffee.
Cold.
Tasty. So, on to maths.
Yes, AQA still from this book. Nice and pink.
Very pink.
Yes.
It's quite exciting, quite beefy, but it's alright. Bit like Core 1.
Yes, it's a lot of new stuff. It's not actually harder stuff, it's just different.
They're sort of like, from Core 1 we had integration, differentiation, which were weird to begin with because they were new. But when you got into them, they were quite easy.
And it's the same with this entire book.
Yeah, all of it's like that.
2 chapters, so...
Right, beginning there are functions.
Yes, that's where we're going to start today, chapter 1, the first of A2.
Well, we've encountered functions before.
We have, but now we're going to take it quite a few steps further with some new words and ideas to do with them.
Yes.
So, about year 6, year 7, you probably did like fruit machines in maths, where you have, it's normally on a computer, you have like a little thing, and you put in a number and you get out a number.
Yeah.
And that's
pretty much what a function is.
Yeah.
You have an input, and then you have an output.
Yeah, that's basically it.
That's pretty much it.
You've seen the donations of that.
Notations.
Notations.
You can make donations if you like, but that's
Donate.
notations. F of x we did encounter last course.
Yep. It's f of x equals something like x squared, then if it was f of, say, 2, it would be 4. Are you familiar with that?
That sort of thing, and that would be your input, and that would be your output.
But sometimes it can be y is your output, and it would equal something like, say, root x, where x would be your input, and for every input you get an output.
But not all inputs would work with that.
No, I mean you can have your 0, 1, 2, 3, 4, 5 onwards.
That would be fine, but why would you have -2? You can't find root of a minus number.
Yeah, if you square root a negative number, your maths teachers blow up.
That's bad.
It is. So, this is where new stuff comes in.
Yeah, you have to use something called a domain. What numbers you're allowed to use.
It's sort of the restrictions of the x, the input. That's what the domain is.
The most basic of these domains is written in our top corner there, and that means all real numbers.
So it could be something, say y equals x. Quite simple.
Yeah.
All real numbers would give you an output.
But you also use your inequalities like I did before. For this one would be helpful. So you'd have all real numbers like that.
All real numbers means everything except the imaginary numbers, root negative
so
1.
fractions and everything. And then you'd say, but greater than 0.
Greater than or equal to 0. It can be root 0 is 0, and that is an output.
So, yeah.
Yes. Then you get stuff like y equals, say, 1 over 2 minus x. Like that. Well, you can't divide by 0, so what would happen if that was a 2?
Well, that would be 0, so that
Wouldn't
can't be
work.
accurate. So again, you'd have to do that, but you just have not equal to 0. And if you haven't seen not equal to, it's an equal sign, a line for it.
So you'd say x is not equal to 2, but other than that it can be...
all real numbers. And that would be your domain. Pretty simple stuff, really.
Yes, and the next little bit in the book goes on to drawing the graphs, but that's something you should be well familiar with from your AS.
Yeah, Core 1 had lots of drawing graphs, and it's pretty similar, because they're the same graphs.
There's no advancements there. If you don't get it, you can go back to Core 1, a bit of Core 2, and have a look at how to draw and refresh your memory.
Yeah, but that's pretty much the same, but then it goes into more interesting functions.
Yes, so we'll get on to that right now.
Alright. Something extra.
Yes, a little bit more on the same thing we've just been doing.
Yeah.
So, we just did it but didn't outright mention it. Something called a rule.
So a rule is the thing you start with.
So,
Like what things we had before, y equals x squared. That's a rule. But not every rule is a function.
no.
There's a few things that quantify a function.
This one is a function. We just did that one a second ago, and that would be all real numbers. But if we had, say, y squared equals x, that's not a function, and why not?
No. Well, functions have to have one output. That's pretty much a rule. For every one input, you have to have one output. And normally, when you're doing this, it's always x is the input and y is the output.
Yeah.
And that's that way stated.
So if you put a number in here, it could give you two possible outputs for y, which means it's not a function, because if y squared equals x would look like this.
And then you have one x, say, here, so that would give you...
Say x equals 2, maybe.
Yep. And that would give you that one and that one.
So
So that's not a function, but it's still a rule, and it's something you can use, but not a function.
And we didn't outright mention that that's a rule before, so we just thought we'd briefly mention that's what it is. So that's not a function. And that's another rule of functions, is the only one output thing.
If we were to have that one way just rubbed out, y equals x squared, you know what that looks like, our graph.
Yeah. Goes to 0, 0 with a nice little parabola.
And then we had, say, this point. There's two different x's.
It does. There'd be a positive, say positive x equals 2, then equally, because it's perfectly symmetrical, this would have been negative 2 if it was that particular number. And that's called a many-to-one function.
It is.
Because there's many x values, in this case there's 2, there can be more if you've got cubics.
Try one output value of that y.
Yes. So there's many-to-one and one-to-one. Can you think of any other many-to-one function graphs, Triv?
I think cosine would work.
That's one from Core 2, you should remember, and you will still be expected to draw even in radians.
Yes, the cosine, sine,
cosine, and even the tan graph.
Yes.
Because they are many-to-one, and in fact it's more than just 2 with a sine graph, because they go on infinitely, unless you put a domain.
Yeah.
And that's that, but the domain isn't the only thing, because you can also concentrate on the y direction as well as restricting it in the x direction.
Yeah.
That's called the range. So it's time to get into some real maths.
There's a range on there.
Meters.
So, we found the range. Was 2 metres.
It was a couple, yeah. 2 meters exactly.
Alas.
Not that far really, is it?
No. So, range.
Yes, and then some more new things immediately after, followed by test yourself.
Yeah.
Is the plan.
Is the plan, and we will follow it. So, is a range like it is in stats? Just like the difference between one and the other?
No, not really.
See,
this is real maths, not stats.
Sorry, stats. They've killed you now, so.
I don't like stats.
Stats.
Stats is real if you want to pursue it at uni, but I just don't like it.
It's not our friend.
So, range, it's almost exactly the same as a domain, except rather than being in the x direction, it's in the y.
Yeah.
It specifies that, if you will.
So we have one of our graphs, say y equals x squared. That pen is running out.
That's fine, I got this now. You can see that, I hope. There's y equals x squared. I think Triv will have to take over, but I'll write y equals x squared anyway.
That's our graph, and we have a domain of all real numbers.
Yeah, because this can go on infinitely in the x direction, as far as it can possibly go, to infinity and beyond.
We also have a range. How do we work out a range, Ray?
Well, the range is like the domain, but in the y direction.
So where it starts.
In the x direction it goes on forever, but in the y direction it never goes below here in y equals x squared.
No, it starts there. That's 0. So the range is greater than 0.
Or equal to 0, because it actually does touch the 0 points before going up again. So that is the range, much like the domain, but y direction. So,
draw that ring around, isn't it?
it's fine, you can just put less than or equal to y, can't you?
Yeah.
But really that should be the other way around, it should say y is greater than or equal to 0, but that means the same thing.
Yeah.
And that's the range, and that can be useful.
Yeah, it's pretty much it. Often you'll have to draw the graph to see where it is. It does make it a lot easier.
If you combine the range and the domain in special ways, you can turn this many-to-one function into a one-to-one function if you wanted to.
Yeah, which can be very useful for big businesses and stuff.
So for example, in this case, if rather than all real numbers, you say all real numbers greater than 0, then that's just this side, and that would be one-to-one.
Ta-da!
In case that's useful.
And that's just the beginning of new things. So next we have composite functions.
Yes. So I'll rub this out.
Okay, so composite function is quite exciting. It's sort of like a function inception. So you have your fruit machine.
Yep.
So you've got another one next to it. So you put a fruit in
two
one,
fruit machines.
and it goes around, puts a fruit into the other one, and that goes around, and then it gives you another thing.
Yes, so it's
Sort
two
of makes
special fruit machines together.
So if we have two functions,
Yep.
like,
Y equals x squared plus 1.
okay, and
say g equals, because they use different letters to say the different things,
yeah,
5x plus 7. Then asking you to do a composite function would look at something like gy or yg of a number, say
so
2.
okay.
Nice and simple. You could also have yy and gg, it puts it back into itself.
And you can put as many as it wants, but you'll never see more than 3 on the floor.
No, 3 with a maximum
Yeah.
in your exam, it's nearly always 2.
So the rule of how this works is you do the inner one. Yeah. That's one that you do first, and then you put the answer of that into the next one.
Yeah, so you move outwards.
So if we do that, so we put 2 into our y.
That would be 2 squared, which is 4, plus 1, which is 5.
5.
But we don't stop there.
No, we're going to do
Then
this
move
one.
on,
Put it into here. So 5 times 5 is 25, plus 7 is 32.
And that would be your answer to the whole composite function.
And that's pretty much as hard as it gets. Sometimes you have to work it out, sometimes it's a bit harder. You can get 2 quadratics and it gets a bit confusing, or your input can be an x.
But as far as the maths is concerned, you just make sure you go outwards and you should get the right answer. It's just arithmetic.
Yeah. And that's alright. Does it get any more complicated than that way?
Sort of does, unfortunately.
Oh, no.
There's composite functions, and then there's something called an inverse function.
Scary stuff.
So if I change colour, I'll use a red.
That's a good plan.
And I think we should take this g equals.
Okay, shall I rubber out what's around it?
Just this bit for now.
Oh,
I'm going to
okay.
come back to the top in just a sec.
Oh, right.
So g equals 5x plus 7. There's something called the inverse function of this function.
Yeah, and this is a one-to-one function.
And what you do is you're basically finding the opposite function of this one. The way you do that is you just treat it as a simple y equals 5x plus 7, and then take everything over to get x on its own. So you have this.
To become x the subject instead of y being the subject.
Yeah. And you want to divide that all by 5,
5.
so you have y minus 7 over 5 equals x. And then what you'd normally do at this stage is you then say y equals x minus 7 over 5, because then x is then your input again for the inverse function, and y would be your output again. So it's
And that would pretty much undo what the first one would do.
yes, and that worked with this one, but I left this one on the board for a reason.
Now, I said it was a one-to-one function, and that's important, because inverse only works on one-to-one.
It would not work for a many-to-one, any of the many-to-ones. It wouldn't
No.
work. You can't have an inverse function.
You get a very weird sort of plus or minus roots of weird things. And we're going to do one a bit later, and I'll tell yourself.
Yes. So they just don't work. There's no such thing.
No.
And this is how you would do this. You treat it as a y equals, just ignore the g, Then at the end, swap it round x and y so that it's an input and an output.
And then maybe put back the letters they started with.
Yeah, so this would probably go back to a G rather than a Y in this particular case.
Also, it's denoted in a special way.
Yes.
So if I'm denoted as G, it'd be to the -1.
Yeah.
That means inverse. Which just makes sense because indices, that's the inverse.
Yes, so in a longer question you might get something like Gx equals this 5x, and it would say what is G2? And then without saying the inverse function it might say, well if that's what this is, what is G minus 1, 2? And then you'd be expected to know that that means inverse, so you'd have to do this step.
Yep, and then work it out. Yeah.
That's about as hard as it gets really, but
It is.
all new stuff.
And that's pretty much functions. I think now we're going to get on to a test yourself question.
Yep, we'll see you there.
Let's crack on. Because I haven't actually done any.
Yeah, it's good, isn't it?
Yeah. Question time.
Test yourself, page 23, question 4 from this book.
Nice and pink and shiny.
And we still do all that stuff at A2.
Don't lose that.
Don't miss that.
Okay, so I'll read the first bit. You
I'll
do
do
it?
that. Yeah,
Alright,
sounds
let's do it. So the function f has domain x is greater than or equal to 4 and is defined by f of x equals, open bracket, x minus 3, close bracket, squared plus 1. AI, so it's part 1, is find the value of f of 4 and sketch the graph of y equals f of x.
Right, okay.
Let's do
So,
that bit.
I'm going to use blue.
Blue is a good colour.
So, first I'm going to do this one, and that's quite easy. F of 4,
Yes.
you just put 4 into here, wherever there's an x.
So let's do that. 4 minus 3.
That's just 1, simple arithmetic. 1 squared is 1, plus 1 is 2. I can do that kind of maths.
Alright, so that's that bit
So I'm
done.
going to write a bit bigger the answers. F of 4 equals 2.
Sorted. Now we have to draw it.
Yes, we do. So,
It's quadratic.
it's been shifted 3 to the right, the wrong way to what you would think, and 1 up, the right way to what you would think, so it's there.
Yep.
Like this. Except it has a domain,
It
and
does.
that matters.
And domain, remember, talks about the x direction.
Yep. And we know that this minimum point here is going to be 3 because it's been shifted 3 to the right.
But
However,
it's greater than or equal to 4. So,
which is about here.
yep, so the rest of the graph doesn't exist, which actually changes the entire function. It's no longer a many to one, it's now a 1 to 1.
So that's my drawing, and that goes on infinitely that way. So
Pretty
there's a
jazzy.
part 2.
There is a part 2. The part 2 says, hence find the range of f.
Well, I actually think we've actually done this.
I think you might have done.
The range is from the minimum point of y to however high it goes.
Yep, the minimum point of the entire graph we've found is 4, and then we've put that in, and it gave us 2.
So that is the answer. The minimum point, well, the range is 2. So you could say
Range is
y is
greater than
greater than 2.
Yes,
Yes. Or equal to 2. That can be
like that.
And that's that.
So that's down to part B. We'll do a swap.
We'll do a swap.
With that, I'll have a red pen.
Nice. B. Explain why the equation f of x equals 1
So I'll write that down.
has no solution.
So it's talking about this graph. So look at this graph. So where is our 1? B. There. I think I might know why, Wayne.
The graph doesn't exist, does it?
It's not there.
And that's why it doesn't exist. That's as simple as it is. This is proving your understanding,
Yeah.
as opposed to your mathematical ability, as it were.
It's not there. That's why it doesn't exist. Ta-da.
And stuff like that does come up in exams.
Yeah,
This is
quite
an actual thing. So. And part C,
Swap
I will
back.
go to green.
Ooh, all the colours today.
All of them.
So the inverse, I'll say that again. The inverse function of f is f to the minus 1. Find f to the minus 1 of x.
We did this just a second ago. You treat it, rather than f to the minus 1 malarkey, you treat it as a y.
Yeah.
So you do y equals, and then you've got this x minus 3 squared plus 1.
But now you want to make the x the subject of the equation.
Yes, and the easiest first step would be to take the 1 over.
Yep.
Y minus 1
Equals.
equals, then you don't need to bother with the brackets. You can just do, well you kind of do, don't you? It's all squared at the minute.
Yeah.
You do need the brackets. So you square it that side is what I would do next, then you don't need to bother about it. Like that.
Yeah, you don't have to expand if you do that.
I didn't see the square at first. Now it's just a simple taking the 3 over, except this is now an item, so it's not within.
Now it becomes outside of it. Square root plus 3 equals x. And that's our answer.
Except you'd normally change these things around a little bit, so I'd
you go back to saying
f of x
equals square root of y minus 1 plus 3.
x minus 1 plus 3.
Well, you can do that, yeah. Instead of x, that makes sense.
And that is how you do the inverse function. There's no composite function in this example, but it's an actual exam paper. 2003, we try our best.
Yeah, we do. Soon we're getting new books, the exams might be a bit more recent.
Yes. Although the course hasn't changed that much, this question could come up just like this.
It could. And that's pretty much sums up functions. I think we should do a summary. It's been a long time since we've done that.
Oh yeah, kitchen chairs.
Wow, let's do that. Summary time.
Oh, that's the first time. All holidays, in fact.
Yeah, the summer in between. And while I've white.
In fact, it's even longer than the summer holidays, because we didn't do videos for the weeks before the exam, because we were preparing for the exam.
Oh goodness.
Must be about 10, 11 weeks.
I've missed you, chair.
I've missed this chair. I've missed the whiteboard more.
I like the whiteboard.
Beautiful. It's all white. It's a board.
That's what I want from whiteboards. If it has anything else, you're pleased.
And as it has a TV on the top.
That'd be pretty good.
That'd be good.
Anyway, back to the summary.
Yeah.
So, functions.
Yes, it's chapter 1, the first chapter of your A2 mathematics in core 3.
Yeah, all very exciting and all quite new.
Yes, you sort of touched on functions and then we've developed them a lot.
Yeah. So, let's start with what defines a function.
Yes.
So you can have rules like y equals x squared or y squared equals x, but not all of these are functions.
In that example, only the first one's a function because that has only one output for lots of inputs, whereas the other one, you could put in one input and get out 2 outputs, and that's not what you want.
And that's
not
a function. No, you have many to one and one to one. When we spoke about just them as many to one, and then one to one we just have one input for one output.
And then you can use the domain, and you can restrict many to ones to a one to one if you wanted to, if that's what you needed.
That'll deal with the x stuff, and that's when you start thinking about real numbers, or not real numbers, in the case may be. And then we get to the range,
which is just like the domain, tipped on its side.
Yeah,
and it's the y direction.
Yeah.
And that's the range, and you can restrict it again in this direction, or you can say real numbers of this or whatever.
And then you have different types of functions, you're pretty jazzy. So we have composite functions, like a function within a function, function-centsion.
Think of 2 fruit machines, you put in a number, you get out a number, then you put it back into another one and get out a further number.
Yeah, remember to start in the middle and go outwards.
Yes. And then you have inverse functions.
Yes, you do. And that's when you turn it on its head, you switch when you're making the main part of your equation. And it sort of does the function backwards.
And you can only do that with one-to-one functions.
Yes, many to one it goes a bit weird. But you can change a many to one into a one-to-one with a domain. As
shown in that last question we did at the test yourself. Yeah. It would have been a many to one, but they restricted it to just the line part at the end, like that, as a one-to-one. And from then you can actually do the inverse.
Yeah, I think that pretty much sums up functions.
This is chapter 1 of core 3.
Sorted. So, as always, if you ask us any questions, send us on the Facebook page or on here. Basically easier to find.
Yeah, you could just message us on our page.
We'll try to get back to you. We'll do a really detailed walkthrough of your question.
Yeah, and some of our questions are already up. You can have a look at them. And just in case someone else has struggled on the same question as you, it will be up there. But you can message us. And that's about it. We also do GCSE, don't forget that.
But until next time, I think we should go on to the next topic.
Yes, I've been Wayne Mack.
Been James from that.
It's time to go hunting.
Oh yeah.
For McDonald's.
Obviously. Oh, I found a hamburger.